Okay, continuing our lessons on gas laws. So the next type of gas law we're going to talk about is called Charles law. And Charles law says that the volume of the gas is directly proportional to the temperature in Kelvin. Okay, so your formula for this is V1 over T1 is equal to V2 over T2. Now, your temperatures must be in Kelvin. Okay, that's super important that when we're dealing with gas laws, you always have to be in Kelvin. Okay, let's jump into example problems. First example problem. A sample of nitrogen occupies a volume of 250 milliliters at 25 degrees Celsius. What volume will it occupy at 95 degrees Celsius? A sample of nitrogen gas occupies a volume of 250 milliliters at 25 degrees Celsius. What volume will it occupy at 95 degrees Celsius? Okay, so we're going to use our formula V1 over T1 is equal to V2 over T2. Now, our first volume is going to be 250. Our first temperature is going to be 25 degrees Celsius. Well, we got to convert that to Kelvin. So to go to Kelvin, we add 273 to it. So 25 plus 273 comes out to be 298. Now our T2 is 95. Let's go ahead and convert that to Kelvin also. Is 368. Okay, so we're going to do 250 over 298 is equal to V2 over T2, which is 368. So when we do this, we're going to cross multiply and divide. So we're going to multiply these two numbers together and divide by this one. Okay? So we do 250 times 368 divided by 298, and you should get V2 comes out to be 308.725 milliliters. Okay, once again, the algebra in that. You cross multiply and divide, so you multiply this number times this number and divide by this one. Okay? Next example. Oxygen gas is at a temperature of 40 degrees Celsius when it occupies a volume of 2.3 liters. To what temperature should it be raised to occupy a volume of 6.5 liters? So oxygen gas is at a temperature of 40 degrees Celsius when it occupies a volume of 2.3 liters. To what temperature should it be raised to occupy a volume of 6.5 liters? Okay, so we're going to use our same formula. V1 over T1 is equal to V2 over T2. So once again, we're going to go ahead and convert our temperature to Kelvin. So we're going to do 40 plus 273 out to the side. So 40 plus 273 comes out to be 313 Kelvin. Okay, so we're going to substitute into our equation. So V1 is 2.3, T1 was 313, V2 is 6.5, and T2 is what we're looking for. So what we're going to do is cross multiply and divide again. So we're going to multiply these two numbers together and then divide by the 2.30. Okay, so T2 comes out to be 884.565 Kelvin. Okay, and last example problem for this little short lesson. A sample of argon gas is cooled and its pressure went from 380 atms to 258 atms. If its final temperature was negative 55 degrees Celsius, what was the original temperature? Okay, so a sample of argon gas is cooled and its pressure went from 380 atms to 250 atms. If its final temperature was negative 55 degrees Celsius, what was the original temperature? Okay, so we're going to start off by converting any temperatures to Kelvin. So negative 55 plus 273 is 218 Kelvin. Okay, so we're going to do so that's not a Charles Law example. Sorry, I messed that up. So on this one, just to work it out, I'm sorry, I didn't realize that this was on the Charles Law worksheet. Okay, so what we're going to do is this actually follows the formula P1 over T1 is equal to P2 over T2. Okay, so this is actually not a Charles Law example because it doesn't talk about volume. It talks about pressure. So your first pressure is 380. Your second pressure is going to be 250. First temperature is 218. And second temperature is what we're looking for. So we're going to cross multiply and divide. You would do this question in the next lesson over combined gas law. So I'm not expecting you to know how to do it for this one. And that's what I get for not working out my example problems ahead of time. I'll post another video on Charles' Law that will go with the homework, including some additional Boyle's Law examples. Have a good day.